Welcome back, friends. As I promised you in my previous video that in the next video we shall be discussing about the all aspect of the hydrogen bonding. Now let I give you a little introduction and a little recap as I told you in my previous video when I was discussing about the types of the intermolecular forces. That hydrogen bonding is the special type of the intermolecular force of attraction, and hydrogen bonding is the bond which is formed between hydrogen and a more electronegative atom. So by definition, hydrogen bond is electrostatic force of attraction between hydrogen bonded to an atom bonded to an electronegative atom such as nitrogen, fluorine or oxygen, and nearby electronegative atom of another or same molecule. So the hydrogen bond can be formed between same molecules or can be formed between different molecules. And as you have seen here that maybe we may have hydrogen bonded to more electronegative atoms such as nitrogen, fluorine and oxygen. So these are just examples of the most common elements which are forming bonds with the hydrogen atoms. So it is the strong dipole-dipole interaction. Strong dipole-dipole interaction. So it is similar to dipole interaction, but this is more stronger. And it is stronger due to different reasons, as we shall see later. However, it also has some features of covalent bonding. So it has like a electrovalent and like a covalent. However, it is strong. So covalent bonds, as we studied earlier, they are weak, but hydrogen bonding it is stronger. So this is the stronger intermolecular force of attraction as compared to the van der Waals forces. Now, let's see what simply happened. So, say maybe, for example, we are forming the hydrogen bond between water and ammonia, because hydrogen bond, as we told you, that it can be formed between the molecules which are similar or which are different. So, say we are forming a hydrogen bond between ammonia and the water. Now, if we are forming a hydrogen bond between ammonia and the water, what happens? Ammonia can be seen like this. This is the ammonia. And water can simply be drawn like this. Now, this is just the simplification. The shape of the water molecule remains the same as we discussed earlier, or as we shall discuss it in the shapes of the molecules. Now, what happens here? This has a lone pair, and here nitrogen is the more electronegative atom, so it will attract electrons towards itself, having the dipole moment from hydrogens. So this hydrogen will be positively charged. And the nitrogen will be negatively charged. Now, listen to me. In water, the electrons will be attracted to the oxygen. And what will happen here now, the oxygen will be partial negative charging, and the hydrogen will be partial positive charging. So, as a result, the partial negative charge in the nitrogen interact with the partial negative charge in the nitrogen interact with the partial positive charge in the hydrogen. That's why I told you that this is the strong dipole, because even here we have the permanent dipoles. So as a result here, the resulting molecule will be seen as hydrogen, then it is nitrogen, hydrogen, it is hydrogen, then here we shall have hydrogen, then it is oxygen, here is hydrogen. It is a positive charge, it is a negative charge, here is positively, here is positively, here is positive charge, and here is positive charge, here is negative charge. So this is what happens when ammonia combined with water. And here, if another molecule of ammonia comes, what will happen here? What will happen here is that here means this hydrogen from ammonia will join here, so it will be positive. This positive will interact with this negative. That's why I told you it is interaction between hydrogen and more electronegative atom. So here, this is our hydrogen bond. But also here, hydrogen bond can be formed because it is between oxygen and hydrogen. Here it is between nitrogen and hydrogen. Here we will have nitrogen as usual, negative, then hydrogen positive. Then here we will have hydrogen positive. So as you can see here, the interaction can be between nitrogen and hydrogen of water. That is between hydrogen of one molecule and more electronegative atom of another molecule. Or can be more electronegative atom of this molecule, that is oxygen, with the hydrogen of another molecule. Here in between you may have a hydrogen bond. So that is simply the explanation about the hydrogen bond and how are they formed. So that is the example of the hydrogen bonding. So hydrogen bonds, they are different from other intermolecular forces because hydrogen bonds, they can be intra or can be inter. Sometimes hydrogen bonds can exist even within molecules. So they can be intra and inter. Intra or inter. As I told you before, intra means within or inside the molecule. Intramolecular, and inter means between molecules. So what we have illustrated here is an example of intermolecular between ammonia and water molecule. But you may have intramolecular, that is more electronegative atom in the molecule can form the hydrogen bond with the hydrogen within the same molecule. So intermolecular hydrogen bonding is an electrostatic force of attraction between hydrogen bonded to an electronegative atom such as nitrogen, fluorine, or oxygen, and a nearby electronegative atom of another molecule, that is intermolecular, of another molecule, can be of the same kind or not. So for example, of hydrogen bonding, there are different molecules such as this in the molecule, in the ammonia and the water molecule, or can be formed between the ethanoic acid molecules and different kinds, but they are intermolecular because they are formed between the molecules. The hydrogen bond between the ethanoic acid molecule can exist like this one. As you can see here, here we have carbon, and here we have carbon, we have methyl, we have oxygen, then you have hydrogen. So this hydrogen forms the bond with oxygen of another ethanoic acid molecule. So here is another ethanoic and here is an ethanoic acid. So that is an example. And we have other examples like that which are illustrated. We have molecules between molecules of hydrogen fluoride molecules, because two hydrogen fluoride molecules can form also hydrogen bond. But we have intramolecular. Now, intramolecular hydrogen bonding is an electrostatic force of attraction between hydrogen bonded to an electronegative atom such as nitrogen, then that fluorine or oxygen, and a nearby electronegative atom of the same molecule. So it is observed in some rings of organic compounds such as orthonitrophenyl and orthohydroxylbenzene. Orthonitrophenyl. So orthonitrophenyl or also, I mean, it is ortho nitrophenyl or also hydroxybenzene. So let's I draw ortho hydroxybenzaldehyde. It is hydroxybenzaldehyde. I know these names of nomenclature, they are sometimes very difficult to pronounce. So benzene can be drawn like this. This is the structure of benzene. And then here benzaldehyde means it has an aldehyde group, that is C double O hydrogen. But when we are saying about ortho means the one carbon from the attachment of the functional group, which is the parent one. So this is the parent functional group. One carbon is here. So here will be ortho. We are calling ortho, meta, para. Just studied it in organic chemistry. So it is ortho, meta, then ortho. Here is the carbon where the parent group is here. You can count it as 1. Here 2 is ortho, 3 is meta, 4 is para. So from there now, ortho hydroxybenzaldehyde. Here it will have hydroxyl group, and that's why it is called ortho hydroxybenzaldehyde. Now from here, as you can see, oxygen is more electronegative atom. We attract electron towards itself. And here it will form positive, partial, negative. And here I am dealing with this, will form partial, positive. And from here now, this here, oxygen is more electronegative also, so it will attract electrons, and then it will form partial negative. You see? Now the partial negative oxygen and the partial positive hydrogen in this ortho hydroxybenzaldehyde, they can form hydrogen bonds. You see? Now this is the hydrogen bond in the ortho hydroxybenzaldehyde. And another example is on the ortho hydroxophenol. Ortho nitrophenol. It's not hydroxophenol. It is ortho nitrophenol. So phenol, it is benzene. You are drawing benzene, and then after drawing benzene, you are adding hydroxyl group. So phenol is simply hydroxyl benzene. This is benzene, and then you are adding hydroxyl group. That is phenol. Now, if you are told ortho nitrophenol, then you are adding a nitro group at the ortho position that I told you. It is the second carbon from the parent group. So you are adding a nitro group here. It is N, then it is double bond oxygen. Then here you have another oxygen. So this arrow means the nitrogen has donated the lone pair to the oxygen, forming the coordinate bond, if you were together with me in my previous lectures. And here now, let's see. Oxygen here attracts electron towards itself, forming the partial positive. And the oxygen here, the electronegativity between oxygen and nitrogen, oxygen is more electronegative than nitrogen. Why that? Because of the atomic size of oxygen. All of these two elements, they are all nanometers, but the atomic size of oxygen is smaller as compared to the nitrogen. That's why it attracts the electron towards itself, forming a partial negative. So the partial positive in the hydrogen can form the hydrogen bond with the partial negative in the oxygen, and as a result it forms the intramolecular hydrogen bond. So these are two examples: the ortho hydroxyl benzaldehyde and orthonitrophenol. These are two examples of the intermolecular intramolecular hydrogen bonds. So now let's see about the conditions of forming hydrogen bonds. So in order for hydrogen bond to be formed, one molecule must have a hydrogen atom bonded to more electronegative element. So for example here, maybe in this illustrated case of ammonia and water, all of these hydrogens have been bonded to the more electronegative atom. In water, hydrogen have been bonded to oxygen, and then in the ammonia, hydrogen have been bonded to nitrogen. So all of the molecules should have hydrogen bonded to more electronegative atom. And another thing is that the electronegative element should have at least one lone pair. The electronegative atom should have at least one lone pair. So without that one lone pair, hydrogen bonds cannot be formed. Hydrogen bonds cannot be formed without the electronegative atom to have lone pair. And this third condition, the electronegative element must have a small size. That's why we give you the example is nitrogen, oxygen, and fluorine. We don't give you the examples like sulfur, chlorine, and things like that. Why? That is because of the atomic size. And between the most electronegative atoms, the smallest atoms, they are oxygen. The smallest atoms, they are nitrogen, phosphorus, and oxygen, because they are the one at the period 2 of the periodic table, as compared to the other atoms below, which are period 3, period 4. They are always has high atomic or has large atomic size. So the atomic size also affects, because the smaller the atomic size will attract more electrons, hence forming the stronger bond, as we discussed before in the properties of the hydrogen bonds, that they are very strong bonds. And let's finalize with the effects of the hydrogen bonds, or significance of the hydrogen bonds. And these questions, they are asked direct. So hydrogen bonds first cause the boiling and melting point to be high. To be high because of the large amount of heat energy required to break hydrogen bonds. So molecules such as ammonia, water, hydrogen fluoride, sulfur dioxide have higher boiling point because of the hydrogen bonding. So sulfur dioxide, water, ammonia, hydrogen fluoride. Sometimes teacher, they ask you this question directly. Explain why. Maybe they ask you, explain why hydrogen fluoride has higher boiling point than hydrogen chloride. However, this has a higher molecular weight compared to this. It is true this has a higher molecular weight compared to this. But the rise in the boiling point of the hydrogen fluoride is not because of the molecular mass as in other compounds, but it is because of the formation of the hydrogen bond. So you must remember, and you must know these compounds. You must know ammonia, that why large amount of heat required maybe to melt, or required to boiling point, melting point. You must know about these facts and these compounds which contain nitrogen, fluorine, oxygen. They are always forming hydrogen bonds, and that hydrogen bonds lead to the increase in the boiling and melting points of the compounds as compared to their corresponding compounds with similar properties. So another effect is that hydrogen bonding causes compound to be soluble in water. So for example, is an example I gave you here, that the ammonia molecule will be soluble in water. That's only because the ammonia has ability to form the hydrogen bond with water. And you shall discuss it more in detail in the organic compounds. Most of the organic compounds, they are covalent, and not most. All organic compounds, they are covalent, because organic compounds, they are made up mainly of carbon and hydrogen, and sometimes maybe oxygen. And as you can see, carbon is somewhere in between. It's not metal, it's not non-metal. Oxygen is the non-metal. Hydrogen also has both metallic and non-metallic properties, as we shall discuss in organic chemistry. But what I want to tell you here is that the bond formed between carbon, hydrogen, and even oxygen, they are all covalent. But now, why some of the organic compounds, they are soluble in water, while other organic compounds, they are not soluble in water? That's because of the formation of the hydrogen bond. Organic compounds such as alcohol or even phenol, this in the example here is the ortho nitrophenol. But phenol or all alcohols, they are soluble in water because they have ability to form the hydrogen bond with water. Even the carboxylic acids, they are soluble in water because they have ability to form the hydrogen bonds with water. But compounds which are not capable of forming hydrogen bonds with water, they are not soluble in water. So simply that compounds soluble in water, they can be soluble by dissociation, and some of them they don't dissociate, but they form the hydrogen bond with water. And by forming the hydrogen bond with water, they can mix together and they can be seen as there is no another compound there because they have formed the hydrogen bond with water. So example is ethanol and ammonia, which are covalent compound, can dissolve in water. And as we studied earlier, that covalent compounds, they are insoluble in water. But here, ethanol and ammonia, they are covalent compounds, but still they can dissolve in water. That's because of the formation of the hydrogen bond. So sometimes you can be asked that why ethanol is the covalent compound but still dissolve in water. You must explain that with respect to the hydrogen bonds. So that's the importance of knowing about the effects of the hydrogen bonding. And the third effect, hydrogen bond affects the density of ice. It makes it to have low density. So ice floats in water because of the hydrogen bonds. And if you read some of the literatures, you will see the stories about the Titanic ship, that it was because of the ice, the huge mass of the ice floated on water. So when the Titanic ship floated in the ocean, then it knocked that ice, and then the ice causes the breakage of the ship, and then water into the ship causes it to sink. So all the facts is all about the hydrogen bonding. When the atoms of water, they join together by hydrogen bonding, and when they form a solid mass, which is ice, that ice will float in water, will have low density. So having low density will cause it to float in water. So ice and water, both they are made up of water molecules, but because of the hydrogen bonds formed in ice, cause it to float on water. And the last factor, the last effect, hydrogen bonding causes dimerization for chemical substance. So for example is the dimerization of the ethanoic acid. So to form ethanodioic acid. So sometimes you may be asked that why maybe ethanoic acid can exist maybe in the molecular mass which is double it is in normal molecular mass. Why the molecular mass of the ethanoic acid can sometimes be doubled and to become the ethanodioic acid? That is because of the formation of the hydrogen bond. So it is enable the molecule to form dimers, and when these molecules they form dimers, Okay, anyway, I wanted to illustrate them to you, but you may just see them in the notes here. Saying maybe this is CH3 and maybe this is carbon, this is oxygen, this is O, this is H, and here this will be partial, this is partial positive, partial negative, and then here we have hydrogen, then we have oxygen, we have carbon, we have oxygen, then we have CH3. So here you will see that it is partial positive, it is partial negative. So here the bond is formed here, and here the bond is formed. These two bonds, they are hydrogen bonds. They of course the dimerization, this one ethanoic acid molecule with this another ethanoic acid molecule. Let I wish you nice studies, and in the next lecture we shall be discussing about the hybridization of the atomic orbitals. Nice studies, and subscribe to the channel, join my Telegram group. The link is in the description below. Ask the question if you don't understand anything for more and more details. Thank you, everybody.